Good day, everyone. I am Hepzibah, who is pursuing bachelor's degree in ACA department. And today I'm here to speak on the topic, discuss on the topic, real-time control systems for metro railways using PLC and SCADA. So as for introduction, the concept to adapt this key SCADA and PLC technology for the improvement of the performance of real-time signaling and train control systems that is used in metro railways. So railway systems actually, these metro railways actually nowadays plays a vital role in this growing transportation sector. Metro railways deliver a fast and convenient travels in the metropolitan cities in the daily commuters. Earlier, it was a track circuit and transmission-based systems. These were used for signaling and train control systems in metro railways. So, as the technology of telecommunications and IT has been advanced, the communication-based trains control systems has now been used for railway signaling and train control systems. But these CBTC systems, that is the communication-based train control systems, have various drawbacks. They have a large attack surface, like they can be subjected to multiple hacking attacks, like network intrusion, data tampering, which eventually lead to security hazard. So therefore, PLC and SCADA is based automation systems that can be used to minimize this failure in this railway system. So first of all, what is PLC and SCADA basically? So what is SCADA? Stands for supervisory control and data acquisition. So as it says in its uh, abbreviation, like supervisory control, it monitors and controls the system. So it uses a control system that uses computers, network data communications, graphical human machine interfaces to manage and control industrial processes. These always interact or communicate with other devices like programmable logic controllers and PID controllers to interact with the other processing plants and equipment. SCADA systems are crucial in control system engineering, so they collect and analyze real-time data from processes. They record and use that data for the display on various graphical interfaces like HMIs. So this enables process control operators to supervise that so-called supervisory control of SCADA, what is happening in the field, and even from a distant location. So next, it controls the process as in SCADA, so supervisory control. It controls the process by interacting with the HMIs. So here we see a small generic SCADA system, and so we have a communication network where a SCADA master is connected and the RTU is there with sensors and actuators. Also, the SCADA master is connected with the HMI as we saw earlier. So, supervisory control and data acquisition systems are essential to a wide range of industries and are broadly used for controlling and monitoring processes. They are prominently used because they have the power to control, monitor, and transfer data in a smart and seamless way, and that's how these are being used in upcoming technologies. So this is also another with single computer. It's a system of SCADA. So where we have an auxiliary memory, CPU, communication interface, and we have the RTUs here in display and control console, and program, that is the input output is there. So next one, operation of SCADA is of around six parts. So data acquisition, where sensors collect the data, like temperature, pressure, and other things, and then the RTUs or PLC transmit this data to the SCADA system. Okay, so next we have the data communication. First we have data acquisition. Next we have the data communication, where the data is sent over to a network to the SCADA central system. So in real time. Next one is the data processing and display, where the SCADA system process the data and then it displays it in a graphical form through the HMI. Next one is the monitoring, where it operates continuously, monitors live data for normal or abnormal conditions. So example is that equipment failure alarms, etc. So next one is the control. So based on the data, SCADA sends control signal back to the PLCs or RTUs to turn equipment on or off at its settings, etc. etc. Next one is the data logging and reporting. SCADA logs data for future analysis, compliance, and optimization. Actually, where our SCADA control panels are used. SCADA control panels are versatile tools that find application across a variety of industries, so including this power generation, water treatment, oil and gas manufacturing, and transportation. Their ability to centralize monitoring, it's basically about the monitoring and literally controlling the system and providing or displaying the data, the real-time data, right? So that's how it happens or in its use. So this enables automated control and enhances safety, also makes them like whatever the data is given is accurate, and we can moreover correct the data or so on. So whether it's ensuring the continuous flow of electricity, maintaining water quality, preventing pipelines leakage, so optimizing production or managing logistics, SCADA systems empower industries to operate with greater efficiency and most appropriate reliability. So this is the PLC diagram or the block diagram. Basic power supply, processor, output module, programming device or HMI, and the input module. So what is PLC? So a PLC is a programmable logic controller, is a digital computer used for automation for industrial processes, such as controlling machinery on factory, assembling lines, amusement rides, or lighting fixtures. So basic operation of PLC are it reads input, process the logic, update the outputs. First it reads, like example from like as usual, it sensors or switches. From that it reads the input, then process logic, like the program, how it is programmed, instructions are given, and with through that it processes the concept, and then it updates the output, like it gives the desired output, like motors, valves and alarms, etc. PLCs are essential components in industrial automation and control system, as PLC has been now in now used in used vastly in the emerging world. And so basic operation of metro using PLC and SCADA both together compiling is the basic operation of metro. So train detection, first one. So it's done by the PLC. Train detection. Sensors detect train posting position on tracks. So they sense whether the train position is on a track. Then PLC receives signals and determines the train location. Next one is the signal control. Next one, based on the train location, PLC controls traffic signals, red, green, etc. So prevents collisions by ensuring safe distances between the trains. And next one is the door control. When a train stops at the station, we see that the train exactly opens and closes the door. Right? So PLC opens and not closes the door automatically. So this procedure is done by the PLC, ensures doors only open if the train is fully stopped. So this is actually an important part of the uh, play, where we have to be careful whether the doors are open after the train is completely stopped. So next one is the speed monitoring. So it's done by the PLC again. PLC limit train speed based on zone. Emergency stop is overspeed is detected. If overspeed is detected means emergency will be given and it will stop. Next one is SCADA monitoring, which is done by the HMI. Displays live data. So train location, speed, door status, alarms, everything is displayed through this HMI. Next one is operators can monitor and control operations remotely. Next one is the fault detection and alarms. This is particularly done by the SCADA. SCADA shows warning for issues, that is door jam, sensor failure, and helps maintenance team respond quickly. Maintenance teams respond quickly. Okay, next one is the data logging. Uh, Again, this is done by the SCADA. SCADA records operations and faults for analysis, used to improve safety and efficiency. Next one. Again. So again, metro platforms view sub-application. So here we see the driver of the trains will control the metro platforms, and the operator of any platform can manage the traffic of the metro station. As we here can see a timer, like t is equal to 0 means traffic light is red. When t is less than 20 and greater than or equal to 15, the doors are closed. When t is greater than or equal to 20, the doors are closed and pantograph collects the power and electrical signal on overhead system is on. So train starts running. Now the train starts running. When t is less than or equal to 100 but greater than or equal to 20, traffic light is green. That means the train starts moving forward. Next, we have the metro stations tracking SCADA system. SCADA system view sub application. So, where metro train starts moving when the switch is turned on, the LED in the control panel view the indicates the proper location of the metro system. The system can track, control, and recognize the location of the train even after a power outage or other breakdown. The emergency light will turn on in case of any fault station, and an alert message is displayed by the OCC in the relevant metro stations on the HMI. Next one is the metro station. Next one is the traction power control and power supply system. So there's the electrical control. Metro rail lines must be electrified with 25 kilovolt. So single phase 50 hertz for overhead equipment to deliver electrical energy to locomotives or trains for operating the motor. The substation, feeding post, and the other equipment at the control post and switching station make up the power supply system. A catenary, that is the overhead equipment (OHE) is used to deliver power to a metro train equipped with a pantograph in metro rail traction system. So the transformer 1 is step down transformer for metro station, and utility load transformer 2 is a step down transformer for the catenary, and transformer 3 is a step up transformer for 132 kilovolt incoming line from generation station. The system is turned on by pressing the button on is not the power control and power supply system, where T is timing tag of process or the tag of slider. Next one. Applications of PLC system. So it's used in manufacturing automation, water treatment plants, elevator control systems, traffic light control, food and beverage industry, automobile industry. So like manufacturing, assembly lines, packaging, robotic arms, water treatment plants like controlling pumps, valves, and chemical dosing, elevator control systems, managing floor selection, door operation and safety interlocks, traffic light control, coordinating signals as intersection, food and beverage industry, mixing, batching, temperature control and processing lines, automobile industry, welding, painting, and engine assembly automation. So next one is applications of SCADA system. So here electric power grid monitoring, oil and gas pipelines, water supply systems, metro and railways, building management systems, renewable energy plants, etc. etc. So electric power grid like real-time monitoring of substations, load control and fault detection, oil and gas pipelines, monitoring flow, pressure, leak detection and remote valve control, water supply systems and monitoring reservoirs, pressure zones and pump stations, etc. Metro and railways, train tracking, station control, passenger information systems, and so on. Building management systems, control HVAC, lighting, fire system and smart buildings. Renewable energy plants, monitoring and controlling solar panels and wind turbines. So for the conclusion, as we have the PLC and SCADA based real-time monitoring and train control system for the metro railways has various benefits. Like this system help in detecting exact location, avoiding train collisions, and opening emergency exit even after the interruption of power system with the use of programmable logic controller. So the system overcomes the drawbacks of the current CATC, that is the centralized automatic train control system, which comprises the automation, train protection, signaling, and operation systems. So if the communication link between any of the trains is disrupted, then the whole system or network will not be effective. Thank you.